Okay, welcome back to Love and the Physics with Mr. Goldthorpe. We are going to take on lesson 1. We're going to start with physics 20. And we're going to talk about position and displacement today. And to start off, I'm going to get you guys to turn to these notes. And let's talk about scalar versus vector quantities. If you want to highlight as along with me, please feel free. First thing is, what's a scalar? Now, essentially, a scalar is something that does not indicate direction. All it does is show magnitude. So for example, when we talk about time, you can have like 15 seconds, but you can't have 15 seconds north. That wouldn't make any sense. So a scalar, direction doesn't make sense for it. And that's the same case for distance and speed. None of those have direction involved. And we can actually relate those three quantities of time, distance, and speed with an equation I'm sure you're all very familiar with. My PDF didn't actually do this one very well, so I'm just going to highlight it here. You have it better in your notes, I'm sure. Here's our equation that we're going to start with. V is equal to d over t. Speed is equal to total distance over total time. And when we talk about standard units, don't forget standard units are MKS. Meters, kilograms, seconds. So the unit for distance is meters. The unit for time is seconds. Therefore, the unit for speed is meters per second. That's its standard unit. Good. So we're going to do a question on scalars in a second here. In fact, actually, let's do it right now. And we'll come back to vectors. So this is an example we have, and it deals with scalar quantities. This gives us a chance to actually do a word problem together. We're going to do a whole bunch of word problems. And I just want to show you a method that will help you be more successful. All right, so you notice here that we have a land vehicle traveling at 1,240 kilometers per hour for a certain amount of time. We're trying to find the distance traveled. And it does tell us in standard units. Now, the first thing we're going to do on the side here is we're going to make a list of the things that we actually have. So 1,240 kilometers an hour is a speed. The letter we use for speed is V. That's 1,240 kilometers per hour. But we want this in standard units, so we need to convert this to meters per second. By the way, do you guys remember the quick way of converting kilometers per hour to meters per second? And the answer is simply to divide by 3.6. And that will give us, so 1240, divide that by 3.6. And you get about 344.44 meters per second. We recommend you actually write down a couple of extra digits so we don't actually have any rounding error. So 344.44, so far so good. Next thing we have is 0.0037 minutes, and that's time. So time will be 0.0037 minutes. Now we want to convert that to seconds. Here's a really quick way of doing so. 0.0037 minutes, but how many seconds are in a minute? Answer, 60 seconds. That's kind of a quick way of doing it. You can use the fraction approach as well if you'd like. And that gives us 0.222 seconds. Answer, and what we're looking for here is we're looking for the distance. So we'll put that as with a question mark. So that's kind of step 1. Make a list of the things that you're given and what you're looking for. Next thing we're going to do is we have to write down the equation that relates them. And we only have one so far. So it's V is equal to d over t. After we do this, well, then we need to actually get the d by itself. We have to solve for d. And you guys show as much work as you need to. You don't have to show all of this work. But we have one term on either side. And that means we want to get rid of the fractions. So if we're dividing by t, we multiply t on this side, and we do the exact same thing on the other side. Notice that we have a t on the top and a t on the bottom, so those t's are going to cancel. And we end up with d is equal to v times t. Good. Next, you have to substitute the numbers in. So v is 344.44. You don't have to show the units when you do your substitution. And 0.222. So you multiply those together. And we get about 76.4667. And that's what our calculator tells us. Okay, we're almost finished. But we have to be careful that our answer is in the proper form. First thing is, do you guys know what's missing in my answer? And that would be units. Units for distance. That would be meters. And we have to be conscious for how many digits we show. Now, because we're doing multiplication, is this based on precision or significant digits? Answer, it's based on significant digits. Now, I want you guys to take a look at the two quantities we have here, this one and this one. How many sig digs are in each of those quantities, and how many sig digs should our answer have? Well, 1240 has 4 significant digits, whereas 0.0037 has 2. And you have to go with the smallest number of sig digs, so therefore this number can only have 2 significant digits. Last question, do we round this up to 77 or not? Now, because the next number here is a 4, it's less than 5, you do not round this up. This becomes equal to 76 meters. Done. Okay, there's our first word problem for Physics 20. So just keep in mind, as we're kind of going through this, the things we're looking for a good full solution. I highly recommend, step 1 here, is to make a list, as you can see on the side. Make a list and convert everything to standard units. Step 2 is to have an equation. Step 3 is to do some algebra to solve for the equation. And of course, step 4 is to put the numbers in and then find your answer. So it's kind of our stages for a full solution. So I encourage you, when you guys do your homework, try to show full work just like this, because this will help you on your written responses. I'll see you in the next part of the lesson.